Hi, hello everyone. How are you doing? I hope you're doing fine today. So, uh, can someone just say something on the chat? I don't know if it's anybody listening or not. Okay. Hey, I hope you are listening. um, okay. Hello, Giancarlo. Okay, finally. Cool. Hi, Cal. So, welcome to this first technical live stream from Penpot. I'm Alonso Torres. I'm one of the developers at Penpot. Um, and yeah, this has been something that a lot of people have asked. So that we do show me the code session. So I hope you enjoy it. But I'd like to know how, if you people are familiar with Clojure. Are you JavaScript developers? Can somebody want to tell me? Are you familiar with Clojure, for example? Okay. I don't see many. Today we're not very talky, I think. Okay, I'm going to continue. So I hope, or this session is more for people that are not very familiar with Clojure. So I've done this. I've done this preparation thinking that the people listening today will be mostly developers or technical people. Most of you, I think, are not familiar with Clojure, so I hope to convince you to at least try it. Um, and yeah, so we are going to go over a few topics. The first one is going to be why Clojure. Then I'm going to talk more about the application, the Penpot application, and the structure of the code. Finally, I'm going to go briefly over some features that we just released. Yesterday, we released the 1.12, I think it is, version with some new features. I'm going to I'm going to show you some technical details. Oh, okay, cool. Well, if you're a designer, it's also fine. But I'm going to show a bit of the behind the scenes how things are done. But I hope you enjoy it anyway. Okay, so first things first. One of the things people have asked a lot of us is why we have chose why have we chose Penpot, Clojure for developing Penpot? And the short answer is just because we love it. It's that easy. I hope you enjoyed this talk. That's it. No, I'm joking. But yeah, we love Clojure. But to understand why we love it so much, I need to go over a bit of our history. So I'm going to share my screen. Okay, no, this other one. Right. So in Penpot, we we are from all the developers at Penpot are from a company called Kaleidos. Kaleidos is a small company based in Madrid. We are I don't know how many, less than 25, I think, or so. Um, and yeah, in Kaleidos, we used to work for other companies. We have been doing web development for a long time. I've been in the company for more than, well, for almost 10 years. And yeah, we've been working for several products, and we've done React. And one of the things we saw is that functional programming pairs very well with React and with web development. So here in Kaleidos, we do twice a year a hackathon. It's a long week hackathon that we call the Pi Week. No, Pi Week from its from Personal Innovation Week. So in this hackathon, we basically try new things. Some of us just try new technologies or new ideas. And one of the things that was born here in Pi Week was Juxbox. No, this is the old name for Penpot. We have to change the name when we um, want to establish a company around the product because, well, as you can understand, Xbox and UXbox sounds very familiar, but we like Penpot more, so it's all right. And yeah, in this hackathon, as I was saying, we do a lot of trying new technologies. One of the technologies we wanted to try is Clojure. Some of us were doing already some prototypes with Clojure, but this was our first big project with Clojure. But I mean, I'm talking about the year 2015. This is the old code repository of Penpot. It's still up there. It's still public, but it's of course unmaintained anymore because we have the main repository. It's a different code base, so we haven't reused any of this code base. Eventually, when the project grow, we dropped this whole code because it was basically hackathon code, and we started a new project. So really, well, I have here some images of the old Penpot. As you can see, a lot has changed since then. Uh, yeah, hello Juan. And yeah, so basically what I wanted to try to tell you is that that we use Clojure because we really like it. So the big question is why we like it so much. As I was saying, Clojure is a functional programming language, but it's not just functional. It's not only functional. You can the functional aspect is just the default. One of the main problems with JavaScript is that everything is mutable by default. So if you have any object, by default is mutable. This is the other way around in Clojure. In Clojure, by default, everything is not mutable, it's immutable, but you can mute things, of course. The same goes for pure functions. We call pure functions the functions that doesn't cause any side effects. For example, if you call the print line to show a log or something in the screen, that's a side effect. It's not something that every time you call that function is not the same result because the for example the console is already different. So for example, but as I was saying, those are just the defaults. Now I'm going to show some code because I'm thinking maybe I'm boring you already. So as I was saying, this is the main function for the front end. By the way, I'm mostly a front end developer, so most of the code I'm going to show is for the front end side. Penpot, the front end and the back end is done in Clojure, so a lot of what I'm going to say is valid for both. In fact, well, I'm getting ahead of myself. Let me show you first this. Okay, so as I was saying, the defaults are immutable data with no side effects. But we can do a lot of things we can do also things with side effects. In fact, we usually try to be explicit about it. some functions in our code are called with an exclamation mark, and this means that it's a function that produces side effects. So this doesn't seem like a very big difference, but it's huge because the defaults are the way that you it's they are very important to model your code and model your application. So in JavaScript, when you try to do immutable code, you have to go to third-party libraries. In fact, you can try something like immutable JS or other libraries more modern, or you can, on the other way to do that is just copying around a lot of data structures. And JavaScript is not optimized for for immutable data, but Clojure is. So that's just one of the advantages of using Clojure. Another one is that everything that we do is data oriented. So to show you that, I'm going to start Penpot. So this is the main repository of Penpot. I just clone. Well, this is a basic clone of the code. We can start Penpot just with one line of a script. Let me okay. And okay, yeah, yeah. I what I did was I ran this line that starts the development environment. Okay. I'm going to start. I'm starting a local Penpot instance in my computer to show you some cool things. Bear with me. Okay, now. Okay, so this is a blank slate Penpot application running locally, as you can see here, in localhost. And yeah, I'm going to do another thing. It's I'm going to activate login log information for this class. Well, this module that we have that it changes. So usually it's in warn, and I'm going to change it to debug. So now this will show something I want to show you. That is what I was talking about. That Clojure is data oriented. So when we create some figures, no, for example, I created a rectangle, and maybe I do a circle, or I can create a frame around them, an artboard. Sorry, you see, we are logging this information. This is a kind of a DSL, a domain specific language, for how to change the workspace. But this is data. This is pure data. So this data that you see here, it's what we are sending not just to the our local copy of the state, but it's also what it's going through the network to the backend, and it's stored in our backend. So for example, if I do a change, can you make the fonts bigger? Sorry, I'll do. The ones, here in the console. Okay. I hope this is better. Okay. So, for example, I'll be doing a change in a shape. You see here on the upper side, we show that it says on save change, and then after a while, change to save. What does that mean? It's as I was showing you, when we do a change, our DSL will change the object locally, but will buffer the change for a time. So the main idea is that if we do a lot of changes, we are not sending all of them back to the server, but we buffer them and then send them together. But this is one of the cool things about Clojure. It has a lot of utilities to work with this kind of stuff, this kind of way of thinking. No, we can do. There is tools that allow us to work with data structures, immutable data structures, very easily. In fact, here in changes CLGC, we see how this kind of works. We basically for this is where the main DSL is defined. So I've seen some questions. Are you using reframe? No, we are using we are using for the front end. We are using a custom framework that is based on RAM. That is basically a React wrapper. So under the hood, we are basically using React with some custom framework for easily access to the templates and the hooks. Yeah, I can show you, for example, we, well, I don't want to, maybe later I will go over that, okay? Okay, so I was talking that the functional programming about the data orientation. Also, a cool thing about Clojure is that, well, as I was saying, we can share code between the front end and the back end. But you could say, okay, but you can do the same thing in JavaScript or other languages. Not that many, but some of them. And it's true that you can do that, but very few leverage the server runtime as do Clojure. So Clojure is defined as a host, as a guest language that it's usually running over another runtime. For example, in the front end, we just use Clojure with the Clojure script implementation. So at the end of the day, we are running JavaScript code, and also this allows us to access the. Sorry, I I prefer to show you the code in GitHub because I think it's easier for you to, if you want to check it, you can see the file I'm opening, because if I use my Emacs, maybe I'm going to open it and you can check for yourself. But yeah, for example, we have this utility module for wrapping some of the access to JavaScript. As you can see, we have access to the whole JavaScript APIs through Clojure script. So even if we are using Clojure script, we don't lose the access to low-level functions. In fact, we do use them heavily for a lot of things. But on the backend side, we can use the same thing, but with Java, the Java ecosystem. So in the backend, even it's the same language and we share code between the front end and the backend. On the backend, we can use the Java runtime and all the Java libraries that are battle tested. That are battle tested for a lot of enterprise level code. So yeah, we think that's another huge advantage for Clojure. More things. Another cool thing about Clojure is that, well, nowadays there are several frameworks that have an interactive environment, but Clojure was, well, the Clojure frameworks like OM were pioneers. Well, Figwheel and other tools were pioneers on the side of interactive development. So I'll show you something cool. For example, I'm going to change. Um, so I'm going to change some colors in our CSS. This is a CSS that we have for well, it's SAS, but yeah, this is the definition of the colors. So for example, I'm going to change this for a beautiful pink. Yeah, you see, this is almost immediate. It refreshes almost immediately. And the time that the delay, the small delay, was because the SAS was compiling, not because if we were using pure CSS, this would have been immediate. Or for example, I'm going to do another change. For example, here in this is the file that defines this page. At the bottom, we have a component here that is the workspace. And yeah, we can, for example, say just hello. Okay, it's here at the bottom of, you can see. I don't know, I think you can see it, but here at the bottom of the screen, there is this H1 that I just write. Maybe, okay, I'm going to a different thing. I'm going to change the whole thing for my hello. So I overwrite the whole page with this hello, and the change was almost immediate. Um, instantaneous, immediate. Sorry for my English, but yeah, as you can see, I did undo the change. I haven't lost anything that I was doing. I'm still working all right. Yeah, as you can see, this interactive um, development it's a huge advantage. Yeah, nowadays you can see them in several other frameworks, but when we started the project, there weren't that many that were this good. So Sprocket asks if we are if we have considered Garden. Yeah, well, there is a limit to the to the closure you can put on your other colleagues. No, but I mean, we have in the team we have some uh, people that were experts in CSS. We convinced them to develop the HTML with Clojure, but to convince them that the but convince them to use also Garden for the CSS was a bit heavy. But yeah, maybe we can try eventually. Okay, uh, more things, more cool things. So I hope you are not bored already because I have more good things to say about Clojure. Okay, so yeah, as I was saying, Clojure does a lot of it's very data oriented. in fact, there is one thing that is so cool, that is Spec. Spec is a kind of a data validation framework that it's done. It's part of the core Clojure core library, so to speak. This is give us a lot of it's like a security net for us, because we have specs for all the data we are sending to the backend. And yeah, maybe if I show you, it's better. So for example, spec. Yeah, and this spec is also shared between the front end and the back end. So for example, the changes I was showing you before, these are its definition. So this is kind of a validation framework for the data we are sending, not just for the data we are sending, also for the data we are storing. For example, we have here, I can show you, let me delete some things. Where is my here? Okay. Okay, so we have some debug utilities that are quite useful when you are developing. For example, I can dump the current selected object to see the data that is stored in the state for this specific shape. If I do that, I can see that this red one has some information. It has a name, it has a parent, a data about their corners, a position, well, a lot of stuff. Uh, yeah, if we, for example, change the radius, add some border radius, and check again, the, oh, sorry. No problem, Pablo. Yeah, you can see the data has changed. But as I was saying, we have a spec validation for the shape data. So in some place around here, as you can see, we have all the possible attributes that the data could contain. One of them is the radius. If we check, oh yeah, it's in another file. Uh, if we check, we can see that we put the validation is not just a structural validation. You can do also validation with a value validation. So for example, we are checking that this Rx is a valid number. In fact, I'm thinking that this is wrong, because it should be a safe integer, because you can have negative corners, I think. But yeah, so that's another cool thing about Clojure. And the last thing I want to, okay, yeah, Sprocket. Thank you for asking. Yeah, Sprocket is asking if I said, because if somebody later checks the video, maybe they won't check the chat. Sprocket is asking if the shapes are rendered on a canvas or are in line SVG. And yeah, it's easy to check. If you check just with a code inspector, you'll see that everything is rendered as a native SVG. So we are not using canvas. And this is one of the main challenges we have in Penpot. Doing this and being performant is quite a challenge. Yeah, maybe later I'll go deeper here. I will show you more low level things later. But the last thing I want to comment about why we are using Clojure, or another advantage of using Clojure is that we can use a thing that in Clojure is called macros. Okay, sorry about that. Can you hear me? My headphones just died because I have them in wireless mode. I hope everything sounds fine. Okay, as I was saying, we are using macros. Macros are a very cool thing. Basically, allows us to add code to change the code at compile time. In other languages, I think in well, I know Groovy, for example, has them. There is a AST, no, AST transformation, abstract syntax tree transformations, but macros go beyond that because they, as Clojure is a Lisp, all the syntax is also a data structure, and and we can do quite powerful things. In fact, our colleague Andre recently did some macros um, to improve the performance of the string concatenation in the application, because it's something that is hugely used inside the application. We have to concatenate um, a lot of strings. He discovered that using the low-level JavaScript uh, concatenation was much more faster. So instead of having to change all the places, he did a macro um, to that does this change on compile time. So for the developer is totally transparent, but it will be much more performant. So yeah, I don't know if anybody wants to ask something of Clojure, or I don't know if it's been clear why we love Clojure so much. Uh, but yeah, I'm open to any questions you have of this. uh, okay, I will continue. Otherwise, cool. All right. So the next thing I want to talk is we received a question on Twitter, I think, um, about how is the application structure. Is there a precision advantage? What do you mean of precision, Sprocket? Okay. Mm-mm. Okay. So about the application structure, as I was telling you, the mm, yeah, it's funny. No, because well, there is one thing that Clojure has a custom rational number, uh, but usually we prefer to. Yeah. Okay, Andrea, I'll leave. I will continue. If you want to answer them on the chat, that would be great. Okay, so we received a question about the application structure. Um, so I'm going to talk mostly about the front end. All right. Um, Basically, we're using a library called Potok. Uh, that well, it's an external library, but we are the ones maintaining it, so really is part of the application. But it's heavily inspired in some of the libraries that you will be familiar on other frameworks, such as Redux or maybe Elm architecture. Uh, Potok uses basically what we have is um, we we separate the state, the events, and the UI in different places. So in the front end, uh, we can check here in the application and main here. Okay, so we have data. Here we define all the application logic. So here we have things like comments or for example, the in the workspace we have some things like the booleans, the transformations, drawing. All these files define events that we throw in the that we dispatch on the front end. So, for example, here we have a start drawing event that could make one of two things. It could change the global state or do some asynchronous behavior. So the events change the global state, and then the global state change the user interface. So, for example, here we can debug dump state. Here, this is a JavaScript representation of the global state of my current page. This is what it's rendering. And if I change something, for example, maybe I could open the assets panel. What this does is it changes the workspace layout through an event and then re-render. So for another thing we have is lenses for so the thing is that if we change the global state, we don't want the whole page to re-render. So we have some kind of like the selectors in other frameworks that focus only on one part of the global state. So the whole thing doesn't have to redraw. And yeah, another thing we leverage apart from React, it's RXjs. We think it's a huge it's a huge plus for us. For example, I can show you the import code. Quite amazing the things you can do with the streams, RX streams, and more when you combine it with Clojure syntax or utilities. For example, you can see here all these operations. Well, I'm not going to try to describe it, but what this is doing is it's parsing a file that you are importing, doing a lot of things asynchronously, like calling, uploading files, and and meanwhile putting everything together in an asynchronous way. So RX for us it's hugely important. Uh, in fact, the Potok library uses it under the hood. And yeah, we think it's a better asynchronous model than promises, for example. Well, that's more or less a small summary of what's the application structure. But to put it in another way, when we started the project, we wanted to use React because we were familiar already with React, and we like it a lot. Also, React has been growing a lot over the years, and the hooks, for example, are a huge improvement if you use a functional way of a functional paradigm to develop. Also, using React for us was huge because we were because the way that it renders in it does a one-way data binding. We could render the whole thing just changing the state. And also we wanted to use RX for asynchronous code because it's, we think, a better model than promises. It's better for composition. And yeah, basically those three things made us define the library that we are using for the application. And I can show you more of how this works. I'm going to remove the login because otherwise it will show too many things. But yeah, as I was telling you, everything that happens in the application, or well, more accurate, everything that the user does in the application throws an event. So we can toggle a debugging flag to see the events that are happening. This will show a lot of information, but you can make an idea. So as you can see, it's the pointer in, position is it's an event, and if I start doing things, you see everything. It's an event that will eventually do one of two things: or modify the global state that will render part of a component or some part of the components, or start up an asynchronous process, maybe a remote call or other thing that we eventually create another event. So for example, if I change this, oh, sorry, you see when the save state timer when run out, this executed some events that were doing the persistence on the backend. But yeah, under the hood, we are using React. In fact, if you see, I have some of the debugging tools here. You can see all the components. Of course, I don't know if this is, I show the the pretty labels because I'm in localhost. I don't think in the production code the tags will be this friendly, but because of the optimizations for when we do the deployment, it does a series of optimization. I think that you lose the name of the components, but I think I can show you also. Okay, I don't remember how this was. I know there is a flag that you can activate to see. I don't use it too much, but I think there is here highlight updates when components render. Yeah. So yeah, that's it. If you can see, now I have activated a flag to just to highlight the things that are changing when I do things. So for example, if I move here to layers, you see, even if I change this, not everything is re-rendering, for example. Okay, this doesn't work very well. Okay, it's fine. I just wanted to give you some tidbits of information. Okay, more things. Uh, okay, okay. So I wanted to show you, as I was telling you before, we just released a new release. We just did a new release just yesterday at the time of so yesterday 1st of March we released the 1.12 yeah and one of the coolest things we did, well, we did a lot of things. I'm going to talk of some of the things I was directly involved, because for me it's easier to comment on them. But yeah, we did a lot of things. There is a whole changelog. Let me disable this, because otherwise, okay. But one of the cool things that we did is that we have done a rework on the workspace. So now uh, we can hide some of the panels to have more real estate, no, to do drawings or whatever. And even we have we have a new feature that is hide the whole UI. So if you hide the whole UI, you have like a full screen drawing here, no? So I can do things like let me, for example, so I can use the whole screen to do things. Another, yeah, and you can also you can also resize the panels, and even you can resize these bottom panels, and you can resize also these new pages. So, oh, I don't know what's happening. Why is selecting me this? All right, I know what's happening. I was selecting the whole thing. All right. Okay, so I wanted to talk about this because I think first it's a quite cool feature, and second because to show you some of the things we are doing. So one of the things we are using here, it's a resizable observer. I don't know if you are familiar with this API. Oh, they have changed. So Resize Observer, it's a DOM, a web, an API that you can activate to check for the DOM resize in the DOM. So instead of instead of yeah, instead of listening to the whole the dimensions of the whole page, you can just check for the dimensions in a specific DOM node. So, for example, so we have developed a hook, our custom hook that checks when there is a change, a resize in our in any DOM element. So sorry, this is not the one I wanted. This is this is another hook we have for the resizing of the panels. But the one I was looking for is this other one, that is the one that uses the resize observer. So as I was telling you before, the even if we are using Clojure, we still have the whole DOM and JavaScript's API to for us. The only things we have to do is to prefix them with JS. Well, there is some special cases. For example, this dot at the end, it's for calling new. So if in JavaScript we will do new resize, resize observer, but in Clojure we have to do it this other way. Yeah, but the cool thing about this is that just like this, we have our resize hook that we only have to send what is going to happen when we do a resize. So here on resize, we emit an event that will change the viewport side. So if let me just print here better here. If I print the new size, you will see that every time I do any change here, you see this is the new size of the canvas, so to speak. It's not a canvas, it's an SVG, but for understand the drawing area, so to speak. And if I change to full screen, you see these are the new proportions that are happening. Also, for changing this, I think another cool thing we are doing, I think, it's we have these handles that what they do is when you start moving, you see, we change a CSS variable that defines the size of these panels. So this is the way we are doing it. Also, this for this we have to do some work on the CSS. We have to change the layout to use a we are using a what's happening. I think it's something for the thumb. I think maybe because of the thumb. You see, we are using a grid template, a grid layout. It's very convenient for this case because our layout is quite grid. The thing is that every panel defines its own size, except the central panel, that it's the one that takes the whole area. So this way, when we change to, for example, to full screen, what we do is remove all the other panels. Maybe I can show you. So what we do is here, this is the viewport header. Okay, so see, this is the header, this is the content, the left sidebar. Yeah, so when we change to full screen, we remove everything and left, and we don't have to change the layout because this workspace content will take all the space. So yeah, that's a cool thing. We've done this release. Another cool feature that we did this release is the guides. Yeah. So now we can have guides and we can snap the shapes in these guides. Yeah, but the one thing we have is we sometimes we have to put like transparent controls because it's a nice trick that we do quite a lot. That, for example, the user experience with if you try to resize this object, if you are using the over only for that small dot, for a user trying to do some things is quite messy to be able to resize, no, or this side or this other resize, no. So sometimes what we do is create transparent areas, for example, background red, opacity for, you see, background blue. No, this is not. Okay, this blue and no, I'm mistaken. Oh yeah. I know what's happening. I'm changing the background, but this is SVG, so I have to change the fill, not the not the background. Opacity. You see, the red area is the area for the resize, and the blue area it's the one that creates the guide. Sprocket is asking for the snap implementation. Okay, yeah. One thing I haven't commented on is that we have a web worker that has maintained some data structures for easier access to well, for more optimized access. For example, the snap data is one of the things that we are maintaining in those in those data structures. We use a balance binary tree with, well, it's basically a range tree that we can query on ranges. So when you are doing a snap, really what we are doing is checking in this optimized data structure if there is a close point here that we need to snap. And as I was telling you before, we are using RX for most of our operations. So I can show you, for example, uh, transforms here, star move. Yeah. Snap. Okay, so here, okay, this is the code for moving shapes. So what's happening is when you have a point, if you don't have a snap, or maybe if you disable, you can disable the dynamic alignment or the snap to guides. Um, this is like it's not, basically this correct snap point is not happening, and we just transform the we do a move transformation, a translation of the shape. But when we activate the snap, the dynamic alignment, this will send basically will send the R position, or the important positions, because our mouse is here, but the snap positions are here. So this snap, what will return is a delta, the difference between our position and the position that does the snap. So maybe I can show you. Let me try. Uh, okay, so this is the snap. For example, snap. I think it's here. Yeah, you see, when when I don't have any point close, uh, the delta is always 0, 0. This means that there is no uh, movement, no? That means that my position is not displaced. It's displaced 0, 0 position, 0 pixels, no? But when I go close to the snap, you see this minus 26. This means that my position, my current position, is not the position real, but I want to move this amount in the x-axis. And yeah, this is done. We try to optimize this by having a data structure that optimizes this kind of access in a web worker. Maybe I can show you some of this. Maybe I will put a worker. Sorry about that. I don't know why my. Can you hear me fine? Yeah. Okay. Okay. So yeah, I'm printing. This is the place where we are doing. We are sending the message to the worker. Um, yeah. So you can see this is the range query is the key thing because we are querying by a range of basically 1 pixel. So we're trying to find possible snaps in imagine a line here, no? This position, what we do is we try to find uh, possible snaps in 1 pixel. Well, not 1 pixel. It's yeah, in a range basically. And when we find it, we do the snap. Uh, yeah, it's mixing because we have other, but that's basically it. It's a, I know it's a huge summary for, but it's really a quite complex functionality. But well, I hope this summary it's enough. But basically, what we do is just changing the shape position depending on a data structure that it's in a web worker. Basically, yeah, you're welcome. So, okay, yeah, I think more or less that's more or less the things I want to talk about. I'm open to questions. I don't know if anybody else have questions or want more information about anything. Okay. Mm, okay. I'm going to remove that so maybe if I can show more. Mm, yeah, Sprocket is asking if is there any way to extend this like a sample plugin repository. Not yet. We are thinking we want. I mean, plugins are in our roadmap, but we are not there yet because basically we are still growing the features before before going full support to plugins. But it's definitely on on our roadmap. Um, we love some contributions. We want to improve also the documentation because it's maybe a bit overwhelming right now for the whole to start doing things in the project. I think this live stream helps. Maybe a lot of people that were scared at the beginning after seeing this video uh, dare to 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 contribute. But yeah, right now it's the only way is just by creating a pull request and changing the code base. The plugins will be a feature eventually, not a short term, more like a long term. When we support them, we want to support them so you can create your plugins with JavaScript, not just Clojure. So we don't want to, for the users that want to create plugins, to force them to learn Clojure, because well, we know we love Clojure, but we know it's not a mainstream language. We know, I mean, the entry barrier is high, but not because of the language. I think it's more of the because of the way of thinking. By the way, I forgot to say that we are preparing a blog post to talk more. Well, Andre is doing. Andre is one of my colleagues in the project, and he's writing a blog post talking more in depth about the why we're using Clojure and the advantages. So you will have a good read there. Um, but yeah, we realized that Clojure is not the most friendly for people. So plugins will be supporting JavaScript eventually. But yeah, as I say, it's more long term than short term. We are focusing more now on growing the platform and having more features. We have a long way to go still. Yeah, more questions? I hope. um, I don't know if any of my colleagues also want to for me to show something, or now uh, no, I'm out of a script. So if you want, now it's the improvisation time. So I'm open to anything you want. And well, if you don't want anything, we can leave it here. It's strange to talk. I'm when I've been in conferences doing talks, you have the visual feedback of people maybe nodding or maybe snoozing or or yawning. But now that I'm talking to the void, it's harder. This is my first live stream. Okay, well, so then I think we are done for today. Maybe I hope this is not one time. You're welcome. I hope this is not a one-time thing. Where maybe for future we can have maybe more question beforehand, so it's not just me talking. Okay, so thank you very much. I hope this has been useful. Um, I think we're done. Bye bye.